Okay, so now this is one of the very most important topic of your moving coil galvanometer, in which we are going to talk about some terms, that is figure of merit, sensitivity of the galvanometer, and we are going to discuss all this in the detail. Now the first thing comes figure of merit. It is denoted by G. If you have seen what is that G value, we have already discussed what is that G. G is nothing but we already seen it is a galvanometer constant, or we have already discussed that G is also called as a current reduction factor of the galvanometer. So what is this figure of merit? Figure of merit is defined as the current which produces a deflection of one scale division in the galvanometer in a given. What is figure of merit? Figure of merit is defined as a deflection produced of one scale in the galvanometer is called a figure of merit, that is I upon theta. Okay, I upon theta, or you can say I upon alpha. Alpha is nothing but this is the factor which we are using, or which we have already used, that you can say here this is 5, because we are using here this as factor as a 5. Okay, now here also this is also, so what is this alpha? This is nothing but here wherever I have written alpha, I can write it here 5. Why? Because we have considered it as a deflection angle will be 5. Okay, so here you can see that what is figure of merit. Now sensitivity of the galvanometer. What is this sensitivity? Sensitivity means, as the name given, sensitivity means when something is very sensible, means someone is saying that my skin is very sensitive, right? So what is that sensitivity means? Why we are saying the children's skin are very sensitive? Because it is very soft and tender, means if anything is going to touch, that is showing the immediate reaction in it. So here the sensitivity of the galvanometer means what? That if it shows a large deflection, even when a small current flows through it, is called a sensitivity of the galvanometer. Now what is current sensitivity? Current sensitivity is defined as the deflection produced in the galvanometer when a unit current flows. Okay, a deflection produced in a galvanometer when a unit current flows. Similarly, what is voltage sensitivity? When a unit deflection produced in a galvanometer when a unit amount of voltage is applied. Okay, so this is what we called a voltage sensitivity and a current sensitivity. Okay, now what is this I? We already know the value of this, so we have substituted the value and we got this NBA upon K, and here voltage sensitivity is nothing but upon CS upon R. Okay, so these factors are very important, that you have to keep it in mind when you are going to study this. Now we are going to talk about the one more important parameter, that is the factors on which this is. So the factors on which the sensitivity of the moving coil galvanometer depends. Here you can see that it depends on the number of turns. Okay, it depends on the magnetic field, it depends on the area of the coil, and it also depends on the factor, or we can say the torsion constant K. Okay, now the question comes at what and how it is depending. If we want to increase the number of turns, so what will happen? By increasing the number of turns of the coil, we can find that the current is also increasing, but this we can increase up to a certain limit. After a certain limit, we cannot increase its value. Why we cannot increase? Because it will increase, or it will make the galvanometer bulky, and it also increases the resistance. Okay, now for increasing the magnetic field, if we want to increase the magnetic field, what we can do, the horseshoe magnet which we are using there, that also we can increase, so we can get the higher magnetic field. Now the third one we will talk about, if we want to increase the area of the coil, what we can increase, but this is also up to certain limit because of the same factor which we have discussed in the number of turns. Okay, now fourth one, if we want to decrease, because this we want to decrease. Okay, the decrease the value of this K, what we have to do is we have to make that a suspension of the wire or the phosphor will be a very small, means K is made small by using a suspension wire by a phosphor, which we have already used in our galvanometer. Okay, so these are the factors on which the sensitivity of the galvanometer depends. Thank you.